Welcome all friends. This is Vivek. I am the co-founder and chief data scientist with CellStrat AI Lab. So we are a leading AI lab and product development company out of India. We have created this platform called CellStrat Hub, which is a easy to use AI learning development and deployment platform. We have a global vision with this platform for mass developer adoption across the world for all aspects of the AI lifecycle, including scaling, development, collaboration, and also deploying AI as an API. Right. So that's the platform we have, and just let me demonstrate the platform briefly. I'll share my screen. So you can see my screen. So this is the platform we have created, CellStrat Hub, and we have more than 1100 users using it already. A lot of folks use it for learning, and then it is also meant for development and deployment of AI on the cloud. This is built on top of AWS cloud. It supports Jupyter notebooks for Python and AI development, and you can do GitHub integration with your GitHub account. Right. So this is a global SaaS platform for accelerating AI development and launches, and there are various tiers available here, but folks who are attending this workshop will be able to upgrade you to the beta tier free of cost, and if you want GPU tiers, you can upgrade to Gamma and Gamma plus tiers. Right. So that's what this platform is, and all of you will get free tier when you sign up, but we'll be happy to upgrade you to beta tier if you contact us. Right. So you can see the various features, the monthly hours of usage, and also the storage included with each tier. And then almost 100 plus projects are bundled for ease of learning and development in Python, machine learning, deep learning, NLP, computer vision, AI, etc. And we are continuing to grow this project marketplace, or packs as we call them, right? It starts with very basic Python and goes to very advanced state-of-the-art AI algorithms. There is extensive documentation to support your journey, right? So with all aspects of the platform. And then you just sign up here. I suggest you start signing up already if you have not signed up. And then it will verify your email by sending you a one-time password to your email. And then once you have verified your email, then you can just sign in, and you'll see a dashboard like this. And so this is the central dashboard for CellStrat Hub platform. And before you start the workspace for coding workspace, I suggest you check out some of these packs, like particularly Python, machine learning, deep learning packs, so that these projects will be automatically added to your account. And once you have done that, and you can start the workspace and launch Jupyter Lab, right? And then you will be able to do online Python and AI development and launches, right? So now I invite our product lead, Bhavesh Laddagiri, who's presenting today's workshop, to take over from here and present this platform in great detail, as well as show you how to deploy the AI models as an API, and all of those details are available here. So I'll uh, give it over to our product lead, Bhavesh. So Bhavesh, are you ready? So Bhavesh, are you there? Take it away. Bhavesh, you are not audible for some reason. You're not audible. Okay, Bhavesh said he'll rejoin, so let's wait for that. Any questions, meanwhile, audience, about the platform which I just started demonstrating to you?
Yeah, it's good to have the platform. Prem Kumar this side.
Okay, Prem.
But yeah, a little inconvenience for me. Actually, I am driving right now, and it's hard for me to focus on the screen. Although I will try to keep listening whatever chat is going on.
Mhm.
Where we can get this recording later on, just to make sure that is also shared
Yes,
to.
yes. We have a YouTube channel, so
Mhm.
we'll be able to put this on our YouTube channel, right? So you can access our YouTube channel. Let me show it to you. All of these recordings are available on our YouTube channel.
So
Let me share.
all the attendees who are attending today will get the link of that YouTube channel or the particular meeting recording. Then that will be a great help, I think.
Yes,
Anybody
yes,
to refer
certainly,
it back.
certainly.
Yeah.
So I suggest if you're driving, drive safe. You can always see the recording later, because
Yeah.
this is a hands-on workshop. Unless you do hands-on activity, it will be hard to kind of understand or grasp. It's a very advanced workshop today, and it's very complex. So you please drive safe and feel free to check the recording later. But I'll leave it to you. And this is our
Okay.
YouTube channel, so we'll be adding the recording here, and you can reach out to us offline as well if you need any assistance.
So
Okay.
today in the class there are only IT Delhi people, or we have people from all the backgrounds.
No, no, we have a massive community. We are working with IIT Delhi, IIM Ranchi, many
Yeah.
other universities, schools, and colleges. Plus, we have a massive community of 15,000 AI enthusiasts, right? 20,000 LinkedIn members.
Got it.
So we our massive
Got it.
community has seen this messaging, not just IIT Delhi. So this workshop is not exclusive to any particular college. This is an
My
open
college.
public workshop. And for all others, with
Okay.
reference
Okay.
to the point which just came up, we are tying up with a variety of universities and colleges across India for providing this platform to all their students. And we have already tied up with a dozen plus institutes, including IIT Delhi and IIM Ranchi and many other universities and schools. So that's what that reference is about. Today's workshop is an open workshop for the public. Let me check. Our Bhavesh, are you here now?
Yeah, am I audible right now?
Yes, yes. Now you're audible. So I'll stop presenting and over to you.
Yeah. Just let me know when the screen is visible. It's visible right now, right?
Yes, it's visible.
Okay. Yeah, so good morning, everyone. I'm Bhavesh, and I'm a product lead with CellStrat Hub, and we are building CellStrat Hub. So welcome to this workshop on CellStrat Hub API, which is a deployment platform, so that after you develop your models, you can actually deploy them as an API. So traditionally, you might be familiar with deploying a model as a Flask API, and then you run it locally or something. So this is similar in that we will be deploying it as an API, but it will be completely on the cloud and obviously for free. So you can deploy your models for free and you can deploy it on the cloud. And we'll also be integrating the API with a web application to demonstrate the use area as well. So yeah, so let's just look at the agenda for today. So the first is we'll just have a short intro to what CellStrat Hub API is. We'll look at a model for based on natural language inference. So we'll talk about what the task is and how we can repurpose that task for zero-shot text classification. So essentially, we'll be deploying a model, NLP model, which can classify text into any category without any training data. So it will be like zero shot. And we'll build the model and the inference scripts. So I'll just walk you through that part, and then we'll look at the API specifications, specifically what an API is and how the request and response is formatted. And then we'll deploy our model. So it's basically essentially 3 steps. And then we'll integrate into a web application. Yeah. So let me just share you the link of the repo that you should be. Okay. So, okay, we'll come to that later. So let's just start with the introduction. Also, if you have any questions, meanwhile, in between, you can always ask them, and I'll be happy to answer them. Yeah. So what is CellStrat Hub API? So essentially, it's a as I think Vivek sir also told, that it's a deployment service, right? So it is a deployment service to deploy models easily without any hassles. So it's like within 15 minutes you can essentially deploy a model, provided your model is already ready. And it's also completely customizable, so you don't have any strict requirements or strict format, anything. So you can have complete freedom over how your input is and how your output should be. So as long as it's JSON encodable. And all the models that you deploy here are actually deployed as serverless APIs, which means you don't really pay for the time that like traditionally, if we were to deploy a model, we would take a server and deploy a model there, right? So even if no one is using our model, we will still be paying for the compute time for the server that is running, right? But here it's serverless, meaning that you only pay for when your model is actually used and not for the idle time. And also it's free, so technically you don't really pay unless you go to the paid options, which are more advanced. And yeah, and also all your models are automatically scaled, so you don't have to worry about your infrastructure or anything. You just have to focus on building your model and optimizing your model speed or whatever, but you don't need to worry about the underlying infrastructure because it's automatically scaled according to your traffic. And essentially every model that is deployed is actually deployed using a Docker container. Just to be clear, you don't need to know Docker to deploy it. It's just what's being used under the hood. And if you are an advanced user, you can access that Docker container and customize it more. If you want more low-level access, like maybe running your AI model on a C++ execution environment to increase the speed of your inference or things like that. So for production use cases and more optimized inference, you do have access to the Docker container, so you have complete freedom over your execution environment. So not the hardware, but the entire software stack, at least. And you can also deploy so in the free tier, you can deploy a maximum of 5 APIs. And overall, in a month, you can access 1,000 API calls. It's per month, 1,000, not per. So 5 APIs means also even in a single API, you can actually deploy multiple models together as a multi-model API. So that doesn't count under the 5, it counts as one API. So that's a plus point for you, even if you want to deploy more than 5 APIs. And in general, for all of these features, there are enterprise options available because there might be some high performance requirements that a particular enterprise needs. So that are all those custom plans are available. So for enterprise use cases. Yeah. So if you have any questions on CellStrat Hub API or anything, let me know. Otherwise, we'll move on to our model that we'll be building today and deploying it. If not, let's move on.
So folks, this is not a very common topic, right? So deploying AI is understandably quite a task, and very few actually have the experience of deploying AI, right, as a production model. So that's why this workshop today, we market it quite heavily, because we understand the community has not had the experience for deploying AI. A lot of discussion has happened on AI. So I do suggest you follow through the hands-on, and you'll be delighted once your AI model is deployed as an API, and then you will become a master at it, and really be able to do so going forward as well. Yeah, go ahead, please.
Yeah, so this is a completely hands-on workshop. So you will also be doing every step along with me as we build the model and deploy it. So if you have not signed up for a CellStrat Hub account, this is the time to do so before you start the hands-on part. So do sign up for an account and be ready. Yeah, so let's look at what we are going to build today. So first we'll look at what a natural language inference task is. So it's a task which is in NLP. So in NLP, there are many tasks, right? There's text classification, there is name entity recognition, text generation, and so on. So one among them is the natural language inference task. So the idea is that there is a pair of sentences. So one we call the premise, and the other sentence or the other part in the pair of sentences is the hypothesis. And the idea is that we take this pair of sentences and label it whether this hypothesis is a contradiction of the premise or it's just neutral, or whether this hypothesis entails or like agrees to the sentence. So let's look at the first example. So a man inspects the uniform of a figure in some East Asian country. So we are talking about a man in the premise, and our hypothesis is the man is sleeping. So technically, if the man is inspecting the uniform of any person in a country, probably he's awake, right? He's definitely not sleeping unless it's a dream, but generally speaking, he's awake. So this hypothesis is a contradiction of what the premise is saying. Similarly, an old and younger man smiling. Two men are smiling and laughing at cats. So these are all completely two different sentences. There is no relation between them, so they are like neutral. And then similarly, a soccer game with multiple males playing. Some men are playing a sport. So this is related to this definitely, and soccer is a sport. So basically these two sentences agree with each other. So that's why this label is an entailment. So this is what the natural inference task is. It's a pretty straightforward task. Essentially it's a text classification task, except we just use a pair of sentences, and our text is, and we have these three specific classes in our classification task. If you have any questions regarding this task, please feel free to ask them. It's pretty straightforward if you want to. Otherwise, we'll move on to how we can like turn this into zero shot. Okay, so I'm guessing there are no more questions. It's pretty clear, I guess. Okay, so yeah. Okay, so now the idea is that this particular task of classifying a pair of sentences as either a contradiction, neutral, or entailment, we can actually retrain a model. So we train a model on the data sets that are available. So there is a very huge data set already available out on the internet, and there have been pre-trained models that have been trained for this task. So what we do is we use that pre-trained model, and then we do something like this. So what we do is, let's say we want to classify a task into three okay, so let's say we have a input task here. So which is that Tesla is launching their full self-driving. So this is a sentence, and we want to classify it into either technology, finance, and business. So we don't have a trained model specifically for this particular task. So what will be or any other task in general. So this idea of zero shot is that you don't really train a model to do any task. You directly use a pre-trained model and extrapolate it to new tasks. So here our input sentence is this. Like our pre-trained model was trained on contradiction, neutral, and entailment. It was not trained on technology, finance, and business. So what we will be doing is we will take our inputs text and use it as a premise. So we'll put our input text as the premise, and for each label, we'll turn it into a sentence. So this text is about technology. This text is about finance. This text is about business. So what we did is we take each of these classes and we created three sentences out of it based on how many classes we have. And we put it into this particular format. It could be any format according to you. So you can always, like, it's all up to you how you want to convert this single word into a sentence. Now the reason is that because NLI was trained on sentences, we can't just have a single word here. It's better, it's more accurate to have, like, it can work, but it's still a bit accurate to keep it like a sentence, to frame it like a sentence. So yeah, so we created three sentences, and then we pair our input sentence with each of them. So as you can see, our input set text is getting repeated over all the three classes. We pair them up as premise in our hypothesis, and then we make a prediction. So our prediction is because our NLI model is trained on contradiction, neutral, and entailment. We'll be having some predictions for each of the class. So for contra, we might be having 0.33, for neutral 0.21, for entailment 0.42, and so on for each of these pairs. Now, we are not really concerned about contradiction or neutral, like unless you have a reason to do so. What we are actually concerned is with the entailment part of the predictions of each of these pairs of sentences. So entailment essentially is whether this text, whether the hypothesis is agreeing with the premise, right? So we can essentially think of entailment as whether these two sentences are talking about the same thing or not, right? So if this text is about technology and this Tesla is launching their full self-driving car, so Tesla is a technology company and full self-driving is a technology. So our entailment would be like something like maybe 0.42. Similarly, it will try to find the entailment of with finance, so it's 0.14 only. For business, it's something and so on. So basically, we'll ignore this part. So we don't want this part. Not able to. Yeah. So we'll ignore this part and we'll only use the entailment parts, and then we'll apply a softmax over it, and then basically whichever is the highest value is our prediction. So in this case, the technology one is getting 0.42. So that means this text can be classified as technology. So this is how we are repurposing a natural language inference model for zero-shot text classification. So if you have any questions, feel free to ask. You might be confused. There's a possibility. So if you have any questions, feel free to ask. Is everyone clear, like what the model is doing, like what we're trying to do with this model?
Yeah, I suspect the NLP classification itself is a very big topic by itself. So that would need a dedicated webinar, right? So we can focus on the deployment aspects of it. In fact, in our AGI course, we discuss zero-shot classification in great detail in one of the modules.
Yeah. Okay. So okay, I guess someone wrote in the chat here. So like if you can also write your questions or whatever you want to say in the chat as well. I'll be looking at it. So do that. So yeah. So if this part is clear, let's move on to building the model. So for building the model, we want to use CellStrat Hub. So we'll be using CellStrat Hub to build the model. I'll be putting the source code here. The source code is in this Git repo. So I'll just share my screen. So once you log in and you create your account, you should be able to see a button called Start Workspace. As I've already started it, and it should be in the running state once you start it. So it can take about a minute or two to start it up. So, and once it is started, you can click on Launch Jupyter Lab. So this will open up the cloud-hosted Jupyter Lab environment for development. Also, we'll be using this environment itself for deployment as well. So it's a unified platform for development and deployment. If anyone wants me to wait for them to start it up, just let me know. Yeah, so I told so I shared the source code link, right? So it's in this GitHub repo. So what I want you to do is you can basically go to code and just copy this URL or essentially just this URL. It's either way. And what you can do is once it is open, you should see a button here. So it's a Git icon button, or you can also see the Git tab here as well. So you can either clone a repository or you can directly clone using this button as well. So you can either click here and go to clone, or just click on this, or you can also go here in the Git menu and clone it. So there are like multiple ways to clone a repository. Just go there and paste the URL that I shared and click on clone. Also use the SSH one. So when you're cloning, use the SSH Git one. Although I'm not sure if anyone has set up their SSH as or not. Okay.
So yeah, sure. I have not set up SSH, but I just cloned it. It cloned fine,
Yeah,
I guess.
yeah. If it's cloned fine, then it's fine. Also, so there's so I'll just repeat this step. So what you do is you open up CellStrat Hub, log into it, start the workspace, and after when it's started, you should see the status change to running, and you should see a button called Launch Jupyter Lab. So when you launch it, it should open this up, and so this is our file manager. So this place where we have all our folders and files and anything. This is our file manager. If you are a new user, it might be an empty folder for obvious reasons because you're a new user. And this is our basically a kernel tab, and this is our Git tab, and then there are some other tabs as well. But yeah, but this is the important part. So what you can do is go to the repo that I have shared in the link. Go to code. You can either download the zip. I think that's a easier way if you want to do that. So just download the zip. So just download the zip, and what you do is go to your Jupyter Lab and drag and drop that zip file here. Okay, just drag and drop it here, or you can use the upload button as well. Either way, so there's upload files, right? Just so you can upload that zip file there as well. I'll just wait for a few seconds here.
So one person is saying, please repeat this step.
Yeah.
Not sure which step. So there are multiple options to get this code in CellStrat Hub. One is Git cloning. The second is uploading the zip file which you have downloaded from GitHub to the Hub account.
Yeah. Are you saying? And do you like? Is this fine? Is there any specific step you want me to repeat? Just let me know in the chat. Okay. Yeah. So you upload this, and let me just expand this. So you should see our zip file here, right? So if you are, so I'll just go with the zip file as it's the easiest way. So just go to zip file and then right click it, and you should see a button called or an option called Extract Archive. So just do that. And also you can use this refresh here. If it's not loading, just refresh this when the refresh icon here on top. And you should see our folder unzipped here. So zero-shot text classified deployment main. If everyone has done this step, just open up this folder and you should be here. You just double click to go inside the folder. Can you please just put on the chat yes or something, just so I know that people are doing it and they have done till this step.
Just confirm on chat if you have reached this point. Just say yes or done.
I'll just wait for. I don't have this code. Okay, you might have joined it. So this is the link here. Just paste it. So this is the link to download the code.
So you can either download the zip, upload here, and extract archive, or you can do Git clone.
Yeah,
both options are there.
If you are doing a Git clone, you have the Git clone button here, and you can paste the clone URI here and then click on clone. Or even in the tab here, clone a repository. Either way, whichever is easiest for you.
Bhavesh, could you just repeat that? Get clone. You can click that button. Which button you are saying?
Here,
okay.
This button.
Okay, that one. Okay, and you have to give the link there, is it?
Yeah. So in your GitHub, if you click on this code here, you should see a SSH link here.
Okay. SSH link.
And just click on copy and then paste it there.
Okay.
It could or it could not work. I don't know. Based on SSH. If it's not, the other way is set. Just let me know if that worked.
Bhavesh, I just copied your URL, which you shared in chat in that Git clone and it worked
Mhm.
with the HTTPS.
Okay.
I didn't have to bring the SSH
Okay.
version of it.
Yeah, if that's working, then it's fine.
Actually, starting workspace is taking some time. From last 1.5
Yeah,
minutes.
starting the workspace takes 1.5 minutes actually. Yeah.
Okay.
So
Just refresh
once
the
it's
browser,
started,
Krishna. Refresh the browser.
Okay. Yeah, now it's started. Launch Jupyter node. Yeah. Yeah, thanks. It's done, Bhavesh.
okay.
It
Yeah.
says cloned, successfully
Okay.
cloned. Yeah.
So yeah, so you should see the cloned folder here, and then you can just go inside it. And there should be 2 folders for everyone. I hope I can continue, right? Anyone else stuck anywhere? Just let me know. Yeah, so once you go inside the folder, there should be 2 folders, 2 subfolders, a model source and a zero-shot NLP app. So this is our web application that we'll be using. We'll come to this at the end. The current thing that we are focused is building the model, whose source code is inside this. So just go inside this folder, and you should see a notebook called Build Classifier. So just double click it, and it should open up your Jupyter notebook. And also, if it is asking for a kernel, make sure you select PyTorch 1.9 as the kernel. So if it's already written PyTorch 1.9, that should be fine. If it's not, then just click on it. Or if it's asking you to select a kernel, just select the PyTorch kernel. Yeah, and once you can see the kernel is like idle or like there's a white filled circle here, just run the first cell with Shift Enter or using the play button, and it should initialize the kernel for the first time. So I'll just import torch and transformers. So as specified, as mentioned, we'll be using a pre-trained model. So we, by the way, you can actually run all the cells till this part. So run all of the cells till this part, till test inference script part, if we can. And I'll just walk through the code. So yeah, so we are basically using a pre-trained NLI model, so a natural language inference model, which was trained for that task. And we'll be using transformers library to load the model and use it. So we load both tokenizer and the model. So yeah, so we just download the model and the pre-trained ones both. So by default, when it's downloaded as cache in a temporary folder. So but we want to like create a separate folder where we'll be storing all our model files. So let's go to that. And yeah, so let's say I have an input like this. So last week I created my version. And then I have classes like mobile, website, billing, account access. So probably something like a customer service text classification thing. I can just run all of the cells. And this is the place where we can define a template. So in the PPT, I had like this text is about finance, this text is about technology sort of thing, right? So which was replacing this part with our class names to frame our classes as a sentence. Yeah, so we'll just use, so you can always modify this template according to you. But yeah, but this usually works fine. And then we have our pre-process function, which will basically take our text classes and our hypothesis template and basically tokenize the inputs and get the input IDs. So just run it and run this. Actually, if you want to look at the inputs, you can look at it. So as you can see, it's 4 inputs because we have 4 classes. So this text is copied, is paired with each of these classes. And so that's why we have 4 sentences and 37 is the max length. Branch. These are our inputs. And now to make prediction, we can just put a forward pass and get the logic from the model. And as you can see, we have 4 predictions because we have 4 pairs of sentences which are corresponding to each class. And we have the contradiction, the neutral, and the entailment predictions. So if you want to just look at which index is what, you can just go to model config.id, and you should see that the zero index is for contradiction, the first index is for neutral, the second index is for entailment. So as mentioned earlier, what we are concerned is with the entailment part. So we just post process it, get the logits, and then just only select the entailment predictions from the model and apply torch softmax over it, and then just post processes in this format. So we have our highest predicted class as mobile with 74% accuracy. We have our website prediction as 9% accuracy, billing as 4%, and account access as 10%. So this sort of thing we have. So after processing it, so this is our predictions. And then now, because one thing generally for any model, be it this model or any model that you'll be deploying, you need to have your model files saved into a folder. Like you need to have them for offline. You cannot always, whenever you're making inference, download it from the internet. So this is currently downloading from the internet, right? Your model deployment will not have access to the internet. And in general, even if it had, that's not actually the best way to do things, because then it will have an extra time to download it. So what we do is we can just do save pretrained to and give a folder name to save it to a folder. So just run these two steps, two things, and you should see a folder in your file manager here. If not, you just refresh it. And you should see all our model files required for our model to run here. So these are all the weights and the tokenizer, the vocabulary, everything saved in here. So if you look at vocab.json, you will look at all the vocabulary of our model. It's probably a very big file, so not worth getting it. But yeah, so just run this step. Okay, so basically run till this part. So till model.save pretrained, run all of the cells if you haven't yet. So let me know if I'm going fast. You can, and if you have any place where you're stuck or wanted to repeat anything, just let me know. I'll just wait for a few seconds here.
So the row number 16, what is the output? What is the inference of the output?
Sorry.
Quick question about the model.
This one.
That log.
Sorry.
Row number 16, what is the inference of this output? Mobile, website, billing, what is
yeah. So this is the, so we had a classes, right? So we're classifying this text into these 4 classes, right?
Okay.
So
right.
our classified results are basically mobile classes giving 74%. So that is the obvious prediction, that's the top prediction. And then we have website.
Okay.
Yeah. And this is zero shot. We can always change the classes. So you can, instead of this, maybe you can iPhone or something, maybe place, and let's see how it refers. Usually iPhone and mobile are same, so let's see how which one is.
Okay, thank you. So after that, you are tokenizing. This is for saving the model, huh?
Yeah, so this is for saving the model, so that we can have offline. Like so that we have all the files in an offline.
Usually we use pickle format also, right? Basically, sometimes.
Yeah, pickle is used for different models as well. This is a transformers model, so this saves it in these formats, and it is used in these formats. But yeah, depending on your model, you can have whatever format it is. So it can be any format, depending on which library or model you're using.
So this supports pickle also, this platform, right?
Yeah, it can support any file. It does. It's completely file format, everything agnostic.
Thank you.
So it's completely universal. So if you are using PyTorch, like a from scratch PyTorch model, it will probably be in a pickle format only. If you're using TensorFlow, it will be in a HDF5 format. If you are using scikit-learn for a machine learning model, then again, it will be a pickle-based saving and so on. So yeah, so it's completely dependent on the model of how you want to save it. Because there's a transformers model, we are saving it in this format because we want to load it with transformers. So.
Sure. Thank you.
Also, a small note: we are using a Distilbart model, so which was trained on MNLI and then repurposing it for zero shot. If I didn't, because I think I forgot to mention that. So similarly, you can use BERT as well or whatever model, but that has to be trained on natural language inference for this to work. So this is zero shot in the sense that I don't have, like, I can give any classes and it can classify the text into any of my given classes. So it doesn't have to basically be trained for these 4 classes or anything. So that's the reason it's called zero shot. Okay, so I hope everyone ran the steps. I am getting a name. Just started from the top. Maybe you missed a cell, maybe you missed to run any particular cell.
No, I have played all the cells actually, so I'm not sure how.
Just rerun it. So just sequentially, one by one, rerun it from the top. Probably missed any of thing. Also, make sure your kernel is PyTorch 1. So the top right, you can see the kernel here, right? So make sure it's PyTorch.
Yeah, no, it is working now. Yeah, I can see.
Yeah, for my kernel it's PyTorch 119.
Yeah. So just rerun it from the top. So it should run. Maybe probably a cell was missed.
So after you run cell number 28, we get this new folder, right? Model files.
Yeah, so we get our model files folder.
Okay. Yeah. I think I got it.
Yeah. Okay, so if you can just put on the chat if I should continue or wait. If I can continue, just put yes on the chat.
So Bhavesh, whenever we discuss our deployment workshop, the process seems to vary a little bit, right?
Well, that's the model part, right? So the deployment is consistent. The model, it's up to the model.
How you create the model file can vary, huh?
That can vary, yeah.
Because for DETR, when we did it, and ant versus bees, so model part is slightly varying. But you are saying deployment lines will be exactly similar.
Like it will be, it should be fine. Like even we can, if you want to convert this into Torch script, we can do this. Except it's a transformer model, so it might be a bit complex. So that's why I separate.
So
I skipped the Torch script part too.
So Bhavesh, we can go with a simple machine learning algorithm also, and we can go with a complex deep learning.
Any model. So so this is just an example, but you can go with any model, anything. Yeah. Even if it doesn't even have to be a model, if you just want to have a server-side code for some web application, even for that you can use it. But that's would not be optimal. But generally speaking, you can run any model, anything.
So this method of saving the model and tokenizer for offline inference, this remains same for all the type of models, right? Nothing much to.
No. This is specifically for NLP models.
Oh, okay.
And for transformer-based NLP models.
For normal models for machine learning, we can go for pickle kind of things also.
So we'll be doing like every week, I guess, a workshop on different types of models. So this is today we are covering NLP. Maybe next we'll be covering object detection and then machine learning and all kinds of models, so that you have an idea of how to do it for every kind of.
Yeah, you're using deep learning libraries, right, Bhavesh?
Yeah.
Okay.
Yeah. Okay, so I guess I can move on to the next step. So okay, so now just on the left, just look if you have the model files folder and just verify you have these files. And then you just go back and you should see inference.py file as well along with this notebook. So this is basically our inference script. So like when you're deploying a model, we cannot use a notebook to run our code. We have to turn it into a .py file. Generally, right? Anything that you can't just run, because notebooks are only used for interactive computation, like interactively just running cells one by one. So in this inference.py script, what we did is essentially we took all of this code from top to this part, so not the save part, but till this part, and put it into a script. So what essentially we did is we created a class called zero shot classifier. We put our tokenizer thing here, and now instead of using this. So now previously when we were doing it, building the model, we used a model from the internet, right? So this Valhalla, Distill, part, MNLI. Now what we are doing, because we have saved our files, we will actually provide a model path to it and then load the files from this model folder. So that will just take as input. So we'll do that. And we define a template. And then we put our pre-process function here. We put our post-process function here. And then we created a predict function which will use all of these functions. So it will pre-process, do the forward pass on the model, and then post process, and then return the output. Just so we have a single place or a single function which can be used for predictions. So be it NLP or anything, you need to have a script. So for any deployment, so this because notebooks can't be used for deployment. So you just use this and you get the output here. Yeah. And in general, if you can, like, it's up to you how you want to put it. Here I just put it into a class, but you can put it all together normally as well if you wanted to. You can even directly copy paste all of these cells into a directly in a script, and then you also use it. Then also it will work. So it should be fine. It's just dependent on how you factor.
Where can I get the key? The key will be in the dashboard. We'll come to that, I think, shortly.
Yeah. We'll come to that later. Yeah.
See,
So,
Bhavesh, what would be wonderful if you could create a cookie cutter deployment architecture, right? Just do it. I mean, I'm finding it needs custom work every time. But yes, I guess considering the supply of AI models is kind of infinite, right? Because AI models come in millions of shapes and varieties. So passing them through a common cookie cutter deployment script is challenging. But okay, we'll see over time.
So this is actually technically not deployment, but rather your own model building part. So
right.
Because even if you're building a model beat, if you're not deploying, then also you would essentially create a script if you want to use it for future reference, future purpose.
So Bhavesh, can we run this script individually also? This inference.py and get them.
Yeah. So in the notebook here, you should see a part where it says test inference script. So where we import our zero-shot classifier and
deployment.
Test. Yeah. Run the script and just check if the script is working fine or not.
Got it.
We have a text, we have our classes, and then we are using the classified .predict function. So we had created our predict function here, right? So we're just using that function and then just getting our output. So this testing of the script is in this part, so test inference script section. And you should see our prediction: technology, business, sports, finance. So just so this was just our model building part. So we have covered the section where we will be building our model.
So Bhavesh, the way we run this deploy the test inference script, right? So similarly, using API, we'll pass this text and we'll get the results back to the API, right? That's what we do, right? Normally.
Yes.
Exactly. Okay. Thank you.
So this was the model building part. If you have any questions regarding model building, we will cover that. But essentially, you can just run the cells till the test inference script part, and you should be good to go. So that was the part where we actually built our model and then tested it or whatever, trained our. If it was a training part, then we would have trained also. But we are using a pre-trained model, so for zero shot. So essentially, for zero shot, the idea is that you don't need to train it. Yeah. Okay, now we'll come to the deployment part. So deployment part is pretty straightforward actually. So the building part is the one where you have, because it's all dependent on your model and it's not that possible to like automate that as well. Now the deployment part is actually pretty simple. So in general, when we deploy a model, we send an API request. We specifically send a post API request. Post API request. So a post is a method of API where you send something and get something in return. So there are other methods as well, like options. There is get method, there is put method, there is delete method, and so on. So usually these are used when you are usually dealing with databases or anything. But generally, the post method is for the case where you give some input and get some output in return. So this is so all our models that you deploy will be using will be sending our input as a post request to our API. So whenever you're sending a request, whenever in an API there is something called the body. So whenever you're sending API, you have header files, headers, not header files, but headers like what kind of content is it, what is your API key, what is your authorization, those sort of things. And then there's the body, which is the actual payload that our model will receive, or at least our API will receive, if not will, but our endpoint will receive. So our request body in Hub API looks something like this. So we specify our service ID, which is basically our name of project. So if you deploy this project with the name zero shot, you just put that zero shot name here. And then you put all of your inputs in the input key. So input key could be anything. Inputs can be in any format, but it should be JSON encodable. So JSON encodable are objects which can be converted to a JSON string. So that includes dictionaries, that includes strings, integers, floats, lists, and all those things. So these structures are all. So if you look at our output that our model gave out, it was in the form of a list, right? It was in the form of a list, or a list of lists. We had technology 0.64 business thing. So this is a list. So this is a valid format for input or output. And then similarly, we have a response that the model gives. So this invocation ID, this all is not given by your model. It is like we add that later on in the pipeline. You don't have to worry about that. But whatever your model is giving as the output is basically in this output key when you receive your response from the API. So basically, essentially what you have to focus on is the input and the output part. So input is what you give to the model and output is what you get from the model. So in our case, in our model API example, we will, so this is again completely flexible and elastic. There is no fixed format or anything in what format should input or output be. The only condition is it should be in a general JSON format. So if you want images, you can also put encode images as base 64 strings. So that I think we covered in the previous workshop, but we'll maybe cover it in the next workshop again. And if it's a audio file or video file, anything, you can convert any bytes. You can just read the file as bytes and then turn it into a string and then send it as well, because in JSON you can accept strings, right? So so basically, essentially with JSON, you can send any kind of file format, video, audio, anything. So in our case, for our model, we'll be sending a dictionary. We'll be sending a dictionary with a key text, which will contain our input text, and then we'll specify our classes that we want to classify this text into. So that would be technology, finance, and business. So we will do this. We'll give this as the input to our model. So our model will receive this dictionary. So this will receive this dictionary as it is. So it will receive this dictionary, and then we will get the text and classes, and then run our inference script on it. And then we will return the output. So our output also was something like this only, right? We had a list of lists. It was a tuple. So with JSON, it just gets converted to list. But essentially we just get technology 0.64 as a probability, business 0.32, finance 4%, and so on. So this is our model output. So so this is how our API works. So this is just a general explanation of how you want to structure your input or output formats. That is completely up to you. There's no strict format requirements. Only it should be JSON inputs and JSON outputs. That's the only requirement. But in that JSON, you can represent technically any kind of file format or anything. So just let me know if this part is clear.
Yeah,
you understood what an API is.
This text and classes are the two keywords what we are using here. Should be in the model also, basically.
Yeah, in the model we will take that and use that. So
Same
we'll come to that
naming.
part how we are. Yeah.
Okay. The naming should be same, or we can change the name.
It could be anything. It could be anything. As it could be any format, any input or output format. But it should be JSON. That's the only requirement.
Yeah.
So which model is currently running?
Sorry.
Which model is this for? Model for generic purpose? Or?
Yeah, this is in general for any, like this is specifically, this particular slide is for our model that we tested now. So the zero shot text classifier model. But
so what does it mean? The technology 0.64, business 0.32.
Yeah, so this is the classification score, right? So we have this text. It classified technology. It classified it as technology with 0.64% confidence. It classified into business with 32%. finance with 4%. So that's like, so our prediction, final prediction is technology, right? Because this is the highest value. Again, your output could be different. You can also, if you don't want all of the classes probabilities, you can just, in your output, you can give only the final prediction as technology, and that's it. No probabilities, no anything. This is completely your choice, like how you want to
So we have to pass the classes also here, huh? As input.
Yeah, that's again, yeah, we decided, like if you want your model to have fixed set of classes, you can do that as well. In our model, we just chose to, so that any user who is using it can define their own classes. But if you want, you can specify classes in your model code itself, so the user doesn't have to specify it. That's up to you again.
No, so Bhavesh, how will this API service global public if we were to expose it to public?
Yeah, just you will share the API key.
I mean, you have to tell them what classes can be passed in, right?
Yeah, that's user. Like if that's again a user deployer, the developer's choice, right? If he wants to provide classes around, if he can set the default classes as well, if that's if that person doesn't want to have any classes or anything. That's again. So this is completely a developer choice. It's not a fixed thing or anything.
So Bhavesh, if you don't mind, just show me in the inference.py file where you take these arguments. Yeah.
So in the inference.py, actually we don't take that. We take it in the auto-generated files that we will be generating next in the next step. So
okay, we can continue. I think we can at last I'll ask some questions. Yeah, thank you.
Yeah. So this just so you know, but how we are going to use it, that will come in the 3 steps of deployment. So again, just to be clear, this input format is only for our model and it is our choice. So technically I made this choice that I want to provide my users the option to specify the classes that, or the topics they want to classify text into, so that it acts as a general API for any text classification. So that's my choice. That's as a developer I made. But as if you want a model, zero-shot model, which only classifies into these 3 classes, you can specify them in your inference code itself. So the user doesn't have to specify, and the user only passes the text. So that is completely a developer choice. So I just want to make that clear. So
this is a REST API?
Yeah, this is a REST API. Yeah, a post request will be made to our API. Yeah, I hope this is clear. Like when we go to the code, I guess it will be more clear.
Yeah, I think when we see this in the CellStrat, we can understand people. Yeah.
And Bhavesh, one question. Why do we say it's a serverless API here?
Yeah, I'll come to that actually. So in the end, I do have a slide on that.
Sure, thanks. Yeah.
So, okay, so let's talk about the 3 steps of deployment. So deployment, so this is the actual part that this workshop is about. So that's deployment. So in deployment, we have 3 main steps. The first step is initialize, where we run a command which will initialize everything. It generates the boilerplate code, the templates, and a lot of stuff. We'll look at what that exactly is in a second. We also, and then we integrate our model, our source files, everything. We put our inference script, specified requirements, and then we just build and deploy. So yeah, so we'll just we'll directly jump into the hands-on part and just understand what this is. Yeah, so I hope the screen is visible. So now after deployment, you should see we have a cell which says initialized Hub API project and then integration and a few things. So what I want you to do is click on this blue button here. So on top right, or top left, sorry, you should see a blue button. So this is called the launcher button. So this is the way how you get this screen, which will basically allow you to open notebooks or terminals or create Python files or anything. So just click on this blue button, which should open this launcher tab. So once you do that, just click on this terminal here. So at the bottom left, you should see a button for terminal. So this is a normal Linux terminal that we'll be using to run our commands. You can actually run these commands from the notebook itself, but Linux terminal is like the preferred way, I guess. But yeah, so just go to this here, and what you do is run up. So this is the command. So I think this command is also mentioned in the notebook. Open a terminal and in the following command, hub init zero shot. So zero shot is the name of our API that we are giving, that are giving. So it would be anything of your choice. But yeah, but zero shot will be using zero shot. So all of you can type this command, hub init zero shot. So where is zero shots is the name of your command. Also, if you want to look at the help of it, you can actually will open up the explanation of the command.
So hub init is a Linux command?
Yeah, it's a Linux. Yeah. Ubuntu and operating system.
No, Hub is a utility we have created, isn't it?
Yeah, Hub is a utility. This Hub is a utility, our own custom
this is not a standard
command line.
Linux.
This is not. This can't be installed in any of Ubuntu or anything. This is a custom thing that only runs in CellStrat Hub.
Right.
Yeah, so this is a command line tool called Hub. So which is used to deployment. So maybe over time we'll turn this into a GUI based deployment as well. But at the moment it's a command line based utility to deploy models. So just run hub init zero shot, and you should see a thing called project initialization at zero shot complete. So just now after you run that command, just do cd zero shot. That will basically, that way we'll just go inside that folder. And you can actually go to that folder by going to your root here. So just click on this folder icon. So that will lead you to the root files here. And you should see a folder called 0-shot. So just open that up and you should see quite a lot of, not quite a lot, but a bunch of folders and files here. So these are all auto-generated boilerplate code so that you don't have to write any of the deployment code as such. So also I did mention that it's a Docker, right? So if you are advanced user, you can use the Docker file to edit or anything. But our main things that we are concerned right now about is these two folders, the model folder and the source folder. So source folder is the place where we will put our source code. So our inference.py script will actually go in here, and all of our model files that we downloaded or saved, right? Either be the pickle or anything .torch script or HDF anything, it all goes into our model folder. So all of the model related files, which are large in file size, essentially. So so we just put those. So it's an empty folder right now. So what you have to do is you have to actually copy and paste them here. So what you can do is just go back to your deployment main here. Just go to the model source and go to model files. And just just select all of the files here. So just select all of the files here and right click on it, click on copy. So you can copy it, go back to the root, go to zero shot, Url, and paste it here. And because they are like 1 GB in size, it should take a few 10 seconds or something. Copy it. You don't really see it somewhere, but yeah, it's actually possible. So you can refresh the file list to see the files there.
1 GB?
Yeah, the model file is the model size is 1 GB.
Okay, because most people here are on free tier, so they have 8 GB storage only.
Yeah.
So we'll upgrade you to beta tier if you reach out to us offline. So we'll upgrade you where you get 32 GB storage space, but you'll have to just contact us offline. We'll upgrade your email to beta tier.
Hey,
Yeah,
Bhavesh,
so yeah.
Can you show how to go to the terminal again?
Yeah. So just click on this big blue button here on the top left, and you should see the terminal here.
Oh, thanks.
Okay. And Bhavesh, what are the files you said we had to copy from where to where?
So from your original repo or the code where we had a notebook and all, right?
Mm-hmm.
So there we had a folder called model files, generated a folder called model files, and we have these files here, right?
Okay.
So just press shift and copy all of the files. Copy it and then go back to the root folder, and you should see when you ran the hub init zero shot command, you should see your zero shot here, and in your model folder, just paste those files here with right click paste.
So, why we are doing this step actually? Not understanding.
So this is the model. So that is only just we saved our model locally, but this is the place where it will get deployed.
So you mean, see, this hub unit will create a Docker container environment in the CellStrat, right?
Yes, yes,
And then we are copying the code manually to the hub.
yes. So this
Okay.
is a so this zero shot is our Hub API project folder. So it will basically contain all of our source code and model files, which will get deployed. So
Okay,
this
so
is our deployment package.
this is in cloud also, right?
Yeah, this is in cloud.
So earlier was a temporary staging environment.
It was
This
only
is
a
now a
development
production
part.
folder.
So there we were just developing our model, just saving our models and running testing it. Now this is the place where we'll be deploying it.
Bhavesh, I think move is better than copy. Now I've occupied 2 GB of space, right?
Yeah, that's fine. That's up to you. If you want to move it, you can just do cut paste also.
Baba, sorry, one more time I'm asking. It's all the source files you have to copy here. .js files.
Yeah. No, not yeah. So this under model files, you should see these files, right? Hello.
Under
Yeah,
model
there's a
file.
model files folder in model source where the original code repo that from the starting that we use. That inside that folder, we have these files here.
Okay.
Just copy them or cut them, up to you, and then go back to the root here. So with this, by clicking on this small little folder icon, and you should go to your project folder here, which is your name zero shot, and paste it inside the model folder with right click paste.
Okay, got it. Yeah.
I recommend everybody delete the or cut it,
Yeah.
not copy it, because otherwise you are
Yeah, if you
occupying
want to
2
cut.
GB of space. Because it will exist in 2 places unnecessarily.
Yeah.
Yeah, you can delete it from the original source. Now, once the model file are complete, the other is you just copy this inference.py script here. So just right click copy it and put it in the, you might have guessed, in the source folder. So I'll just repeat it again. Now, after you copy the model files, we also had our inference script, right? Inference.py. Just copy that file or cut that file, up to you. It's a small file, doesn't really matter. And go to your project folder again, and in the source folder, so zero shot src source folder, paste it here. So along with these 3 other files that are already there that were created by our hub init command. Yeah, so once that is done, just let me know. Just put a chat yes on the chat or something. Also, while you're cutting, pasting the model files, which are large in size, it can take about 10 seconds or something. It will just automatically.
Yeah. So source file is in model source. You are saying?
That inference.py is there. Just cut it from there and paste it in the new source file, source folder here in our zero shot folder.
Okay.
So this is essentially a deployment package. I'm just repeating it again. So the other place where we generated all these files or created them was just our development part. We just developed our model or trained our model, whatever. This is the place where we deploy. So that's why we are moving those files to this particular location.
So that part we can do in our local Jupyter also, right?
Yeah, you can you can do it in your local files also. Anything you just have to upload
the
them.
memory also in that sense.
Yeah. Yes, anything. So it's you can bring your model from anywhere. You just have to initialize the project in Hub and then put the rest relevant files. If it's a source code file or .py scripts, you just put in source folder. If it's a model related file, just put it in the modeling folder. So just put in the chat if you have done. If you're done copying and cutting the files, whatever, both the model files and the inference.py script.
Actually, copy pasting is taking some time, I think.
Yeah, it takes about 10 seconds. It's a 1 GB file. So 1 plus GB, actually, I think 1.4 or something. Okay, meanwhile, I'll just explain the part of how that API input and output is doing that. So once you paste this here, you should, in your source folder in your deployment project, you should see 3 other files. One is called main.py, one is called requirements.txt, and another is called utils.py. So for this particular project, utils is actually just a general file. It doesn't, you can put your any extra utilities here, but essentially we provide a default utility for converting A64 payments. So this is for vision models. This is an LP, so it's not really relevant today. But yeah, so the main.py, just open the main.py here. You should see that there's some already boilerplate code here. So this is the actual script that actually runs when you invoke your model. So this handler function is the one that gets invoked, and your input is accessible in this inputs variable. So essentially what you will do is we'll import our inference script here. So similar to how we did it in build classifier, right? We imported zero-shot classifier and put it here. We'll import that same here. We'll create a classifier, but instead of specifying model files, we'll actually specify this. So this model there is equal to os.get and model there. So when we copied our files in this model folder, what it actually does is when we deploy a Docker image, those files are accessible at this environment variable. So environment variables are essentially variables which are global to the operating system or your deployment environment. If you are new with Linux or anything, and our path to this model folder where all of our files are present is accessible at this model underscore their environment variable. But yeah, essentially this is a general line. This is consistent across all of your model deployments. You'll always be able to access your model files of anything inside this model folder under this directory path.
So we have to add that line, right? Model directory equal to.
Yeah, it's already commented. You can just remove the comment here to just put it there.
Okay, yeah.
So yeah, so what we'll be doing is, just copy our import. So we tested our thing here, right? So we just put the import statement here. So from inference import zero-shot classifier, because we have just copied our inference script as well into this same folder, right? So we do that, and then we initialize our zero-shot classifier. So instead of specifying model files, we'll specify model variable.
So can you send those in chat?
So this actually the entire source code for main.py is actually available here. So in your notebook, you should see all the source code here. So you can just copy this part and just replace everything. Just everything replace it here. In the notebook, in the build classifier notebook, there is a section called integration, and under that you should see the steps. So this first step we already did. So copying the files from model files to zero-shot model 4. Now we'll be replacing the main.py code with this code. So just so you know what we changed exactly from the previous is we added these 2 lines, this line. So we imported, we created our model, and this was already there. All of this, we maybe added a print statement here just so we can print it out when we check the logs or anything. So yeah, so and our inputs. So our inputs. So in our inputs, if you remember, we were having a dictionary, right? We decided that the user should give a dictionary with the text, key, and the classes, right? So those are accessible in this inputs variable, which is already there. So we didn't really add that. So because it's a dictionary, we can just do inputs text to get the text and the inputs classes to get the classes. And that will basically give our output. So that's the only thing that we changed. So this 1 line and these 3 lines. So totally 4 lines are the ones that we have changed from the original main.py. And again, this repeating the source code, the changes, the final code with the changes is available in the notebook here. You can just copy this thing and then replace it in the main.py.
Bhavesh, 3 lines. You have added imported your zero-shot classifier.
Yes.
right? And model directory classifier. What else? What is the fourth
Yes.
one you were saying?
The last in the line 29, you should see output classifier.predict. So this is the
Okay.
place where we are using our prediction function from our inference script. We are passing the input text. So our inputs is in the form of a dictionary. So text key as our input text and inputs classes as our classes.
Okay.
So
Again,
we need to change this main.py file according to our model requirement, basically.
Yeah, according to your model.
Okay. Okay.
So
Some
mostly if you
syntax-
already have a predict function, this is sort of essentially the same. You import your predict function at the top. You probably load your model here, or you can load it there as linear inference script, and then you run your predict function here. Generally, usually it should be 3 lines or 4 lines of changes, but essentially the rest remain same. Basically, your inputs, the input that you get from that our model receives originally is this dictionary called inputs, which is already there, and then you can access the keys there. If it's not even a dictionary, if it's just a string, then that's also it. We'll just receive that. So whatever. So in our PPT, we had our inputs, right? Inputs it had a dictionary. So in our original model spec, we decided that we'll be passing a dictionary as input, right? So which will have text and classes. So this entire part, so this value of this inputs in our API request is accessible in this inputs variable here. So that's what is happening. And then because we have text as the input text and then classes, we'll just use that here. So because our predict function from our inference.py takes these two things, right, as the input text and the classes. We use that, and then we get our output, and then we don't need to change anything. The output is the variable which is already being returned here. So you don't need to change anything there. Essentially, you just replace that. So if you have done this part, just let me know. Chat.
So predict is the main function in the inference file, right?
Yeah.
Yeah. So it takes text and classes and gives the output as a written output. Yeah, we are done with it.
Yep. So yeah, so once that is done, one last thing that you have to do is go to requirements.txt. So in your source, you should see a requirements.txt file, right? Just double click on it, and it's an empty file. You can add your requirements. In our case, we need PyTorch and transformers library. So these are the requirements that we need to run our code, right? So these are the library that you want to use. So this is because when you're building a Docker image, it needs these information so that you can install those libraries. So we just add. So again, this thing is again present in the notebook. So in the third step here mentioned in the notebook, add the libraries in requirements.txt, torch and transformers. Again, this is model that if you are using maybe scikit-learn or anything, you would specify sklearn here, scikit-learn here, sorry, and maybe pandas or numpy or whatever if you are using them. So that is so just to reiterate, we copied our files from our model files folder to our zero-shot model folder. We copied our inference file as well, inference.py in the source folder. We replaced our main.py to use our predict function here. And then we also added our requirements.txt libraries in the requirements.txt. So these 3 things we did. So just once you're done with that, so just put a yes in the chat or anything once that is done. Okay, so I'm guessing everyone would have done this part. So once that is done, the next thing that we have to do is so the next thing that you have to do is actually build and deploy our model. So what you have to do is just go back to that terminal that you initially used, and make sure you're in the respective folder of your project folder, deployment project folder. So that is 0 shot, and run this command hub build. This command is again mentioned here in the notebook. So I think here it's written hub build, hub deploy. So just write that, then just press enter, hub build, and this can take about 2 minutes or something to build the Docker image. But even if you don't know Docker, you can just think of this process as creating your deployment sort of thing, like deployment image.
So that means Bhavesh, hub init will create just a folder structure, and now we are just creating all the Docker container images, everything, right?
Yes.
Okay. And then we are deploying the next command.
Yes.
The hub build must be run in the right folder, right? In 0 shot.
Yeah, it should be done.
Yeah.
Even if it's not, it should work. But like generally,
No, how will it work outside of that folder?
There is a extra flag that you can mention, so you can like write hub build and IP and specify the path.
I need to know the project to build. Yes.
Yeah, but generally it's easier to just, if you are just cd into that, just run hub build.
It's kind of like the make process, like we used to do make
exactly.
files.
Yeah,
it's like a make process,
something
project
like
make
that.
process.
Yeah. So this is like that in case of like C++ and all. If it's like, let's say, a web development project, then also you would basically init a web project and then build it and then deploy it. So this is similar to general web development or C++ projects or those sort of things.
But here only Python code, right? So it is like C++.
Technically, you can run C++ as well. That's because it's a Docker, so you do have full advanced control over your execution environment. So technically, you can access C++ as well if you want to increase your inference speed. But generally, for AI models, Python is like easy to use. So yeah, so Python.
I'm getting a error. Warning actually.
Yeah, warnings. That's fine actually. Just ignore those.
Like it says, running pip as root user can result in broken permissions.
Yeah, that's fine.
I've shared in chat.
Yeah, that's fine. Then you can just ignore that actually. It's because the Docker is the user inside Docker is a root user, so that's why it just says that. That's fine.
So internally we have a EC2 running, and on top of it we have a Docker container, right?
Actually, it's not actually exactly EC2. So I'll come to the part of how this is actually working at the end and what things we should remember when deploying models. So this hub build, once it is complete, you should see a successfully built the image. You can deploy a model with hub deploy now. So deploy. You should start deploying your model. And so now it is basically pushing our Docker image, our entire Docker image to the cloud for deployment. So this can again take 2 minutes or something to completely deploy. Okay, so meanwhile this is deploying. So again, just to reiterate, run the hub build command and then run the hub deploy command. Okay, so just run these two commands sequentially. So once that, while the process is happening, what you can do is go to your dashboard here. So the CellStrat Hub dashboard here, just go there. And on the top, you should see a button called deploy models. So just go there and you should, it might give a pop-up if you are new to the Hub API. Just close that and you should see something called API key management, and you should already see a default API key here actually. So in your API key, just click on this click here to reveal API key and click on copy to clipboard, or just manually copy it whichever way, but generally copy to clipboard, and you should have your API key copied. And go to back to your notebook here and replace the place where it says your API key here. Now, because you are using an API and this model is specific to our user or your account, we authorize our account with this API key.
This is in build classifier notebook, is it?
Yeah, build classifier notebook. Yeah, build classifier notebook. So if you scroll down to the part where it says test the deployed API, you should see a place where it says your API key or this API key, paste your API key here, and then put your API key here that you just copied from the dashboard.
That is within quotes,
Generally,
right?
sorry?
Within quotes, no? API key, yeah.
Yeah, within quotes.
Within quotes, yeah. Okay.
So Bhavesh, can we see that this model is deployed in CellStrat front end anywhere?
Yeah.
You can see it? Or?
Yeah, you can see it. So once this deployment is actually complete, so like in my case, it's saying deployed in progress. Once it's complete, you will actually be able to see your deployed model APIs here. So yeah, so just wait for the deployment, and then once that is deployed, show you that part as well. So your deployed models and how many locations, what were the inputs and outputs, all of that history is actually visible in the dashboard. So for your model, the logs, you can view the logs for your model as well in the dashboard, all of that.
Yeah, thank you.
So it's deployment in progress. So yeah, just paste your API key. So just to reiterate, go to the dashboard, click on deploy models, and you should see an API key here. Click on reveal to API key, click on copy to clipboard, and then paste it in the build classify notebook where it says your API key. So originally it was API key here, right? So just paste your API key here. Also, this is the URL essentially that we make our API request to. So it is api.cellstrathub.com/synchronous. So we'll come to what synchronous means and what is synchronous and all that at the end. So we'll cover some extra points. And these are our headers. So we specify X, our API key, under X-API-key header. And then we also specify content type as application JSON. Because our inputs and outputs, as mentioned earlier, is always JSON only. So yeah, so just run that cell. So run this cell, run the text and classes, and yeah. And then just go back to the terminal and check if your model deployment is complete. So in my case, it says model deployment completed. Okay. So once that is completed, just run this last cell which says payload. This is where we are specifying our input. So we had our actual input is our model input is here, but we also specify service ID. So service ID is essentially the name of our Hub API project or the name of this folder. So in our case, it was 0-short, right? So we specified 0-short. We specified our input. We also, again, because this is JSON encoded, this is compulsory. You always have to put your input as json.dumps and put your more inputs here. So in our case, it's a dictionary. So, but it can be strings or lists or anything. But regardless, your input should always be json.dumps to encode it as a JSON string. And yeah, and then we basically make our post request. So we make our post request. We specify our Hub API URL. So this is our URL for our API. We specify our headers, which also contains our API key. And we specify our json.dumps payload for our data here. And then after making the call, we can just do .json so that we can get our response in JSON format. That's the idea. Also, the first time when you're running this, it can time out, and it probably will time out. So yeah, so as you can see, when you're running it for the first time, you should see this message called endpoint request timed out. And it happened, and it would always happen at 29-second mark. Whenever like you're running it for the first time or after a while, I'll come to this exact point on why this happens and how to deal with it, etc. Yeah, so when you run this first time, just rerun it again. So once that is done, just run this cell again.
So Bhavesh, I got the error status code 500.
Me too. I'm getting status code 500. Internal AI model error.
Same
So,
thing, yeah.
Yeah, so probably your AI model. So okay, so I'll just come to that point in a second.
Yeah.
So just run this. Yeah, so for those for whom it is working, so after the endpoint timeout request, you probably would be able to see your predictions here. So as you can see, my text was something about Tesla's autonomous driving, and I had wanted to classify it into technology, sports, and business. And I got my predictions for each of those classes, like with the probabilities. So this is, so now we have just tested our API in Python. Now, what you have to do is, for those who are getting the error, or if anyone, even if they have not gotten the error now, but they might get in the future. So what you have to do is just refresh your deployment dashboard here, Hub API dashboard here, and you should see your deployed model here in the dashboard. It says zero shot here, right? So just click on it, and just wait for this to over. So this will basically show your logs. So if you are facing any kind of AI model error, so currently I didn't face any, and yeah, so this was my print statement in the main.py. So you can see as you can see. So you can view your API model logs from the last whatever number of hours. So by default it's 3 hours. Also you can click on again query logs if you want to again.
It says no logs to show from last 3 hours.
Just retry it. Just click on query logs again. Maybe yeah. Also,
So for me, it says no module named torch traceback. Unable to import module main.
yeah. So in the requirements.txt, make sure did you mention torch? Just cross check.
Oh, okay. We didn't do that. Okay, that part we missed.
Yeah. So in your case, that's that. I think someone else was also getting an
Yeah,
error.
Krishna here.
Yeah.
In my case, I don't think there is an issue.
Just cross-check something. So the first thing is check if you have your requirements.txt file filled up with torch and transformers.
Yeah, in requirements, I'm just saying.
Are missing.
No, I think I closed it, but I have put those text.
Okay.
I
Just
think once you enter it, you should save it also. The problem is that I did not save it, so
okay.
not getting
Yeah. So
automatically
by the way,
saved.
generally when you make some changes, you should see this. You see this white dot here. So this is an indication that the file is not saved. So we can just do Control S to save it.
Now it's working. Yeah. Thank you.
Yeah.
So in my case, it is there actually. Requirements,
Okay.
torch and transformers are there.
Okay. Yeah. Okay. Now go to main.py.
I mean, do I have to do hub build and deploy again after changing
Yeah, you would have
requirements?
to. Like if you're changing the anything in the source code you are changing, then hub build is required. So
No, but then I already deployed it. So how do I?
You just run that same command again. It will just
Hub build and deploy, build and deploy both.
Build and deploy. It will update that model.
It will update the existing deployed model, huh?
Yeah, existing deployment. Yeah, so anytime when you make changes to anything inside the source folder, you always have to run the build command again and then deploy it, and it will update your existing models. It won't create a new model, it will just update it. So this is how you update your models or make changes and all. But if you change anything in your model files, that in that case, model build is required, but it actually runs fast because then if you didn't make any changes in source, it will like cache and run fast. Generally, as a rule of thumb, if you make any changes, just run your hub build and deploy again. Yeah, I think Krishna sir, just go to execution logs and click on query logs again. It might sometimes takes a minute to update the logs.
I'm seeing the main.py. It says classifier equal to zero shot classifier. Within parenthesis, model directory is there. No, I think end parenthesis is not there.
Oh, yeah, just make sure.
But it won't give source code error if I do that.
Like it should give, like just go back to the dashboard, just run the query logs again. Like sometimes it doesn't store the logs immediately after you run. So
it is again saying no logs.
Yeah, just query logs again. Click on this query logs button. Maybe change this from 3 hours to 2 hours or 5 hours or something.
Okay.
Just try again. You should be able to see the logs. Is the logs visible?
I think it is. No, again it is showing same thing. I've done 3 times. No logs to show. Fine, maybe.
Yeah, maybe it didn't even get started to execute. Yeah, probably it just gave the error at the syntax level.
Yeah.
And
so now in the main PY, as you said, no, I can see
just,
that.
Just what you do is just copy the source code again, just so you know there's no mistakes or typos.
It was coming for me again. I refreshed 2-3 times. It got. I guess I got the logs now.
So actually, I didn't copy fully. Only that 4 lines, right? Model directory.
Okay, yeah, that's fine. You can copy fully as well. Actually, copy fully will work. So just do that, just so you know there's no typos or anything. Those parentheses are typo, right? So just copy this full code again from the notebook and just replace it for the entire thing.
Okay.
Just click on Control S to change the file.
So Bhavesh, once we have the model, the process is exactly same in the previous two Ant, Bees and DTR, right? Once
Yeah,
we
the
have
deployment process is consistent across any kind of model. Only your build part and your model code is the one that changes.
Now saving, yeah, I did that.
Yeah.
Yeah.
Now just run the. Also, before you run it, just make sure you have the model files in your model folder in your model folder, just so we can catch anything before we again rerun the build and deploy.
Where you are saying in the zero shot?
Yeah, in the zero shot folder, there is a model folder, right? Just check if you have all 7 files, I think.
Yeah, checking that.
So model will be created as a bin file.
Yeah, so essentially what actually happens is when this Docker image is being created, it actually doesn't store the model files in the Docker image. We store this model files in a separate storage server, network file storage. And when you're running the code, it actually fetches the model from there. So the reason is that way the Docker image is smaller in size because model files are usually very large in size, right? So that will slow up the Docker initialization or the initial call for your model. So that's why we separate the model part and the source part.
No, why it is creating as a bin file? Bin file means
Achha, that's the model thing. So that's a model. So it created as a bin file. So, but essentially it's still again bytes only, just named with that bin extension. But yeah, that's just a tribe library that is storing it. So we're using the transformers library, right? So to build and train save our model. So it's the format that the library uses.
So usually the bin file means we can specific to the particular platform. Okay.
Yeah, that is specific to the library. Yeah, that's where it's.
So Bhavesh, I suspect automating this good part of this whole process through GUI is quite difficult because there are quite a few coming from different kind of models. I think the environment can be different, so it's really hard to sort of GUI create a GUI workflow out of this.
The only way this can be automated is if we have a AI sort of model which will actually scan our code files and automatically integrate and do the stuff.
No, that is not viable. So as of now, command line looks the easier way. Creating a cookie cutter GUI looks very challenging, right? So we'll have to do it with command line. Command line may be the easier way still.
Also, just so you know, give your logs by up logs and the name of your model.
Yeah, Bhavesh, now I have to build and deploy, right?
Yeah, you have to again build and deploy.
Yeah.
So by the way, yeah, so you can also view your logs from the command line. So by default, it views from 1 hour. If you want to specify an hour, you can just do -h and give a number. So let's say I want from the last 3 hours. Okay.
Oh, logs. Correct.
Logs.
Okay.
Yeah, in the terminal as well. So this is the logs are accessible, and you can also save your logs to a file as well. That's also possible. So logs dash see the help window for the commands. You have hours options. You have save directory, which will save the logs to the file. These sort of things are there. In general, there are 5 commands total in the hub utility. Just do hub-help, and you should see the build, delete. There is also delete command that you can use to delete your deployed model permanently.
Okay.
And the init and logs as well. Yeah, so for those whose models are deployed, and even if they are deploying, we can move to the next step. So while it's deploying, actually, what you can do is, even if it is deploying, just go to the launcher. So just click on this big blue button here and launch another terminal. So we'll just use a second terminal. Just launch another terminal. It should open this.
Sorry, just to take a step back, why does it time out first time?
Yeah, so I'll actually come to that. So that's because of the cold start.
Okay.
For the first time, but I'll come to the exact things.
The lambda function cold start, huh?
Yes.
Okay, now second time it worked for me.
Yeah, so, because now it's loaded into the memory. So.
Okay.
So actually, the thing is like your this is a synchronous API, and it should finish in under 29 seconds. So usually the cold start, depending on the model size, it can take different amounts of time. But usually it's like more than 30 seconds. So that's why it.
No, what does this mean? So let's say I call this API from a client, and I haven't called it in many days or weeks or months. So it will time out.
There's actually a method. For the first time, yes. So there's actually a method to actually overcome that. So I'll come to that point in the last slide.
No, so the client developer has to know first time it will always time out if I come back after some time.
Yeah, so there are some things to know when we are deploying. So there are, I'll come to that exact full explanation there. So that part is covered, yeah.
So for that one solution is that you can kind of a ping kind of APIs support,
Yeah,
right?
ping, yeah, that ping is actually there. So if you notice in your main.py, you should see there is something called load. If your event is load, it is used to load the model into memory. So the exact API to run this load is not yet available. Like maybe by next week, it will be in the next few days, it will be available. But you can essentially use that different API to load your model into memory before you make your predictions and then run your predictions. So this can be, if it's a web application, you can, whenever you open up a web application, it will run the load command. So on startup of the web application, it will run the load API and it will load the model into memory and then you can make
So
predictions.
does our documentation say that, Bhavesh, that first
not
time?
yet. Actually, yes, the endpoint thing is mentioned, but not a very full explanation. So
we
I'll
need
add
to
that
tell the
point
client
command.
developers that it's in cold start, it will time out. So
Yeah.
try again like that.
Yeah. So yeah, so like once I again in the next 2 or 3 days, I'll add this load API. So along with that thing, I'll add the
You don't want to keep it warm also, which is incurring cloud cost.
actually,
right?
yeah, keeping warm is actually incurring cost. That's maybe available for a extra fee. So users can opt for an extra warming plan. So that on an extra fee.
No, we don't want to keep it warm because why to incur cost?
Yeah. Also, if the user would want to keep it warm, they can just run a loop in their web application that will ping the model every time, but it will consume their API calls. So that's
no, that's not viable either. But yeah, for the free tier, we should not keep it warm.
Yeah.
I think AWS has got something, right? CloudWatch or whatever,
Enterprise.
Some ping thing is there, right? That every 15 minutes or half an hour, just
that's fun. Yeah, we do have that actually. We actually tested it. It's already there in place, but we disabled it. We would probably use it in the future or like for paid situations. And also for enterprise customers, this cold start problem won't really be there because it's a complete production use case for a company and many users will be using it. There is provisioned concurrency as well as warming facilities for them. So, or even if for an individual developer, if they want a warming, they can opt in, but that's an extra fee, so they'll have to pay that. Yeah, because warming will actually cost extra.
Bhavesh, I have got one question, right? So this Lambda has got some restriction on 250 MB or something like this, right? How did you solve it? How did you solve it?
Yeah, I'll come to that. So yeah, I'll come to that exact point in a second. So, but yeah, I guess I can say right answer. This is short answer. So essentially, Lambda has made a lot of changes since last year. So I think in December they introduced a lot of changes in Lambda. You can have up to 10 GB of RAM in your Lambda function. You can have, if you use a Docker, your storage is again limited to only 250 MB, but a Docker. But if you're using a Docker image on a Lambda function, it has a 10 GB limit. So again, we have 10 GB of storage. That's more than enough for any model.
Oh, they increased it.
Yeah. And as for the timeout, you have up to 15 minutes of timeout. But generally, the API, for the synchronous part, at least, it's only 30 seconds we have because of API gateway. But yeah, generally speaking, like even if your endpoint timed out, it actually keeps running in the background. So technically, you can see your invocation for the model in the invocation history here, even if it had timed out. So generally speaking, but apart from that, yeah. So so these things are covered, and also for batch inference and all, we will be that's on the roadmap. Currently, this is only for cases where you have single inputs or short number of inputs, which can process within 29 seconds. So that would be. But for batch inference on, we'll be using Elastic Container Service and all that to run batch jobs for longer periods of time. But that will come on later, and that will be probably based on for the time you are using the. So this API call is based. So this metering is currently done based on the number of API calls, but the batch inference will be based on the number of the time that you are using for inference. because that depends. So, okay, so I'll come to some more explanations on these things at the end. So I do have a slide here, please to keep in mind. So, but I hope everyone's models are deployed or being deployed at least. And you have tested your model here. I've already tested your model here. What I want you to do is go to the launcher. So click on this big blue button here and open up a new terminal. So I've already opened it up. And go to your original folder. So our original folder was named zero shot text classified deployment, right? So just go to CD, zero shot text classified deployment main. Just click on just go to that folder. So not the project folder, but this folder here. Just go there and then again CD into zero shot NLP app. So CD zero shot NLP app, and inside this you'll actually see the source code for a web application. So it's a React based application with Tailwind CSS for the styling and all. This is not a web development, so I won't really go over the code of this. But this web application, what you can do is once you CD into it, you have to run yarn install. Copy this as well in the chat. So this. Then the first command that you have to run is yarn install, and then the next command is yarn start. So yarn install will actually install all the libraries required for this web application to run. So just run that. Again, you can also deploy this web application as a static by doing yarn build. So these things are actually mentioned in the GitHub repo. So you just cd into your zero shot NLP app folder, run yarn install. So yarn start, what it will actually do is it will run the development server. So that is the development part where you edit code. If you want to build the production web application, you can use yarn build, and it will build a static application which can be deployed in services like Netlify or GitHub pages and all those sort of things. Netlify is generally the better way to do this. Okay, yeah. But anyway, that's out of the scope for this. But yeah, so once you run yarn install, just that will run your development server, and you can see starting the development server. So this is basically running your web application in CellStrat Hub. And now once it runs, it will actually expose the application at port 3000. So
what was it? Yarn develop?
Yarn start.
So yarn start, okay.
Yeah, so I think I put it in the chat as
well. What is yarn?
Yarn is a package manager. So for Python, we have pip, right? So similar to that for web, for Node web development, Yarn is a package manager. It's similar to NPM. If you are aware of it, but it's
creating a temporary URL like we did with the
okay,
app.py Flask.
Yeah. Yes. So yarn is just the package manager and the tool. It's like pip or something, or conda that we have heard about. So yeah, so it's basically so it is currently launching the temporary or the development part. So you can see it's exposed at 3000. So what you can do is just go to your URL here on top. Just copy the URL part of it, not the other part, but only the till the .com part of it. So just copy that. Go to a new tab, paste it, and put :3000.
Sorry, after yarn install, did you run anything or?
Yeah, yarn start. After that, you run yarn start.
Bhavesh, sorry, I got stuck with this one. When I say CD zero shot text classifier deployment, it says no such folder exists, file or directory.
You can just do zero CD and do zero shot text and hit tab so that it auto completes the exact path.
Yeah, it actually completed classifier deployment.
Yeah, and you go inside it.
Yeah, so when no, there itself it says no such file or directory.
Make sure so when you opened up the terminal, make sure you're in the
it says it is in base.
Yeah, so make sure you're in slash hub if you're not already there. Probably you should already be there. Just go CD. Go short.
1 second. So how do I see? What did you say? Short? Sir, I didn't get that. Hub.
Just you're looking at my screen, right? So CD colon slash hub, like if, but you should already see it. Are you seeing this thing at before the dollar mark?
No, this is the folder what we downloaded from the GitHub.
You have to go to that folder. Yeah, so you have to go to the folder that we downloaded for GitHub.
Maybe I'm not.
Just go to CD.
CD hub slash hub. Yeah. Now I'm there. Now you are saying CD.
It's for MLP app.
Just do ls listing ls minus lrt where you are currently.
Okay. Yeah,
See
now it went. I think I was not there. CD hub. Yeah, got it. LS.
Just check in ls where you are.
Okay. Yeah, thanks. Yeah, now actually I went to that. Yeah, now it changed to the directory.
Okay.
Yeah. Okay. So afterwards, what needs to be done?
Yeah, then go to CD zero shot NLP app folder. After that, you go into the GitHub folder.
Zero shot.
Go to the NLP app.
NLP app. Yeah. Okay.
Yeah, and then just go inside it. Yeah, and now run yarn install and yarn start. It's in the chat, so just check your chat for yarn install and yarn start.
So yarn install, yarn start. Okay.
So Bhavesh, this folder was already there in this GitHub, right? Did you did all these configurations earlier only?
Yeah, I did that.
All the files? Okay.
Yes.
So is it a major change or just to copy all the files or something? I mean, what should we do before this?
For the web application. No, you don't have to do anything. You just run those two commands. All of them are.
No, for us, if I want to create this folder right from the scratch, there are a lot of work involved.
That is, yeah. Well, that's the web development. Yeah, that's actually a bit of work.
Oh, okay, got it. Okay, understand.
That's complete from scratch web development. So.
So React
can be
app,
used,
right?
The code can be used, right, for the other.
Yeah, it can be reused actually. So if you are able to figure out the code, you can just go to source and click on app.js. And if you are aware with JavaScript,
just to understand where should you change that? If I delete a new model, I should change somewhere. That's
yeah. So in your app.js, you should see I put the zero shot. So this is the place where we are making the API call. So instead of service zero shot, you might.
Man, one more problem. What happened? See, instead of zero shot, I gave something like some other name now. So I should go and change it now, right?
Yeah.
Okay. So otherwise, my web will not work.
Yeah, then it won't. You have to change it to zero shot. So just go to app.js in source, and you should, I guess, line 57 or something.
Bhavesh, I did that yarn.start. Afterwards, now I have to copy that URL, right?
Yeah. Now, Now go to the top of your browser. You should see the URL, right? Just copy the .com part, paste it here, and then add colon and 3000. So this is the port number where it's running.
Okay.
So Bhavesh, only one place to change or any other place? Service ID.
Yeah, that's the only place.
Okay, thank you.
Yeah. So once you run it at 3000, you should be able to see your application rendered here. And this is where you will paste your API key. So I made it general, so like you don't have to change source code. So paste your API key in this text box here, maybe different specify classes. So
so you enter your API key again. We have to copy from there, right?
Yeah, copy from there. And now you can specify some text. So
okay.
Copy and maybe some text here, maybe specify classes.
The URL copy can you show again because it's not properly working for me.
Yeah, so just after you
till here we are done. Yeah.
Okay, so on top you are seeing this URL, right?
Oh, okay, yeah.
So just take that and after that put 3000 by putting a colon over there. So colon 3000. Because it's running on the cloud, right? So it's basically essentially using a server, so you have to access the URL from there. It's not local.
So EC2 name and then the port number.
Yeah. Yeah, and then make zero shot. Again, if you have been idle, so in this case, I have been idle for quite a long time, so it will probably.
No, we can put any text or specific text.
Any text that you want to classify. Put your classes that you want to classify by separating them with a comma, and then put your any random text that you want to classify.
Yeah, I just put a text like I love sports, and also it gave sports as a major prediction.
Yeah,
I tried that. Yeah.
Also, if you're running after a long time, it would probably would have given a pop-up saying me loading the model or something like that. Just retry. Just click on OK that, and then just rerun it. And you should see, so in my case, I am talking about Tesla. So I have technology as the top prediction, and then I have sports for some reason, and then I have science as the next prediction. Similarly, I can maybe try something.
So this is the endpoint URL we should normally give to the client side, right? Basically.
So this is only for the web application. The actual URL that is being used to make the API call, that's the same URL as we have done in the notebook. So this HTTPS API cellstrathub.com/synchronous. Again, in here as well, and you will be able to see that we are making the post request to this particular URL.
And here we are input has only one value and prediction, right? So can we pass multiple inputs also?
Yeah, you can, but you have to change the model as well, because currently we built a model to accept only one input, but you can change it. So that's
the model development. Okay.
Yeah, it's the model development.
So I put about the recent news of Kashmir attack, right? So it classified it as 40% sports and business 26%, technology 24%.
Yeah, maybe you can put something in classes.
I mean, it could not find anything to do with Kashmir attack, right? Recent which happened. So it just
you can maybe try put news as one of the political news or something as one of the classes.
Let me put another category here.
In fact, I have put politics. I put Joe Biden ordered US military to vacate Afghanistan. It says politics 58%. Actually, the beauty is here, the classifiers are dynamically you can define, right?
Yes. Yeah, that's why it's called zero shot. So we can, it's a general.
No, again, this is a model. This is a model development, right, Bhavesh?
Like, yeah, this is the model development.
So nothing to do with deployment, right?
Yeah.
Right. Yeah. So whatever the powerful we develop the model, that much we can use it.
Yes, exactly. Right. So whatever model you deploy. So generally, when we so usually the idea is that if you are creating any models, make sure they are like general, so that people like these that people can use for anything. And again, if you want to actually deploy this web application, so as a permanent URL, so this is currently only temporary, because as long as CellStrat Hub is running here, you can actually use something called Netlify, but maybe we can cover this somewhere sometime later. But there is a service called Netlify to deploy these web applications. So only for static web applications. So this is actually a static and dynamic. It's actually called Jamstack or React-based app. So this the exact thing that we are using here to build this web application is React. React is a Facebook library for creating web front ends using JavaScript, and then thing used for styling and all. But that's anyway, that's the development part, not relevant for AI development per se. But generally speaking, you can actually build this. It's also mentioned here also. You can just do yarn build and create an account and just deploy it actually. That's possible. But yeah, so this is
So Bhavesh, as I said, right, the naming I did not give proper initially. Then I changed the name. But before changing, I had already run yarn build, yarn.
Yeah, that's fine.
Everything. But then I changed it. Still is working. So is nothing related to that one part, right?
Yeah. So like the idea of a development server is you can make changes while it is running, and then it will automatically get refreshed.
Okay. So if I do changes for the React or whatever after the yarn also, it will work basically.
Yeah, it will work. Okay. It's a development version, so it will automatically, it has real-time updates to the. Yeah. So
Bhavesh, one question, right? This is the same model. How do you deploy it, right?
Yeah, this is the model that deployed.
Okay. So these classes and things, how it is making a dynamic stuff?
So this is actually based on something called natural language inference. I think probably you missed it, I guess. But the idea is of a natural language inference task. The idea is that we have a pair of sentences. One is called the premise. One is called the hypothesis. Um, and the idea of a label we predict into three classes. So either contradiction, neutral, or entailment. Contradiction is when each of these sentences contradict each other. So for example, in this case, the man is inspecting something, but here it is saying man is sleeping. So they are contradiction, right? They are not true to each other. And then entailment is when they are both same thing, when they're talking about the same thing and they agree with each other. So in order to repurpose this NLI task for zero-shot classification, what we do is we train a model on NLI task normally as you would, as a regular text classification model. And then what we do is we turn our classes as into a frame text. So we frame for example, my sentence is Tesla is launching in their full self-driving. And I have three classes that I want to classify it into: technology, finance, and business. So I created three separate sentences for each of these words. So I just framed them into sentence by putting this text is about, by prefixing it with this text is about. And then I created three pairs out of it based on, because I have three classes. So I just repeat their input text here and pair it out with each of these class sentences. And then I make an NLI prediction, and I will get again three predictions for contradiction, neutral, and entailment, right? Generally, it's any multi-class classification, we get three predictions depending on number of classes. But entailment is the one that we are concerned really about. So we take the entailment part, and whichever one is the highest entailment score is the one that acknowledge that it is classified into. So this is how basically zero shot is working.
Okay. So it means that the levels should be standard English words and things, right? Whatever.
Yeah.
Okay.
Labels should be English. Actually, I think this is a multilingual language model. So I guess other languages can also work. I think the pre-trained model that we used here to run this, it was a multilingual model. So I think you can see it's called MNLI. M means multilingual. So even if I guess in other languages, theoretically it should work, but I have not tested. So, but yeah, I guess it should.
If you could go back to slide, Bhavesh, 1 second slide.
Yeah.
So here you said based on ENT will determine technology, but the next line, the ENT is less, right? How do you determine finance and the business?
Yeah. So for each pair, we'll get three predictions. We'll get three class predictions, right? For contradiction, neutral, and entailment. So for all of this, we'll only select the entailment part. We ignore this part. This part. Only get the entailment and apply a softmax over it on the predictions. On the entailment predictions of each, and then we get that. In the code also.
So the value what is showing below is the entailment value only, right?
Yes, it's actually the entailment value. Yeah.
Okay, got it. Yeah.
So I guess in the post process you can see we are basically taking the entailment part only, so entailment index, logics, and then applying a softmax over it to get the probabilities. That's what this is. So this is all entailment values.
Got it. Yeah.
So this model which we are using, pre-trained, was not available as an API on the anywhere, right? So now we have basically taken a pre-trained model and deployed as API. Am I right?
Yes.
We haven't added any model value. We are using a pre-trained model, deploying as API.
Yes.
Okay. Because that is the problem we are trying to solve, I guess, for all folks here, that there are a lot of pre-trained models, but you have to integrate them.
So for NLP, generally, the APIs are technically available. Like even for this model, actually, there is an API available.
From Hugging Face API, yeah?
Yeah, from Hugging Face. But it is only for NLP parts. But this platform is a general platform for any model. It's generalist. Hugging Face is like a specialist for NLP, but we are like a generalist for all topics.
No, but Hugging Face is publishing Vision Transformer now. So
yeah.
So they may launch.
But again, there's a specific format and everything. So you can actually not launch any model there.
I mean, they only do transformers, I guess. Which
only transformers. It's only transformers. Purely it's a transformer company.
So we'll create a wrapper for almost all algos in the world, and we'll launch them as API.
Thing. So it doesn't really matter what model it is, where you're bringing from it. You can deploy a machine learning model, you can deploy a deep learning, you can deploy.
So Bhavesh, this is a good one for our API marketplace. It's very generic.
Yeah.
Right. So this is a good one.
Yeah.
Okay, one question. You said that we are doing a softmax on entitlements across sentences, is it? I missed
Yes,
that
yes,
part.
across sentences. Yeah. So as you can see, I think here we are specifying the dimension as 0, and we are basically getting in your logits.
Okay.
There was somewhere. So our logits are something like this, right? So this is the contradiction, entailment. Contradiction, neutral, and entailment. So this is the last column is the one that we are
Mm-hmm.
considered that is. Yeah. So yeah, so this last part is the one that is relevant to us. So in my logits, what I can do is I can select the last column, so that I'll do, and I'll get this part, right. So all this is all these values, and then I can apply a torch software. And I'll have this and then and then I get the related probabilities for all of the classes.
Okay.
So usually, I mean, in the tree values, we are considering only entailments, right? So
But
based on that, based on the concepts, we can go with neutral also, right? Basically, it's again
yeah,
model
like
concept.
technically, I guess you can go with contradiction if you want to detect if how strongly your class is contradicting. So if you want to increase the probability of, let's say, news, you can include contradiction as well. Because let's say if a class is particularly contradicting to this text, then this probability will reduce more, right? And the other part will get increased and so on. But yeah, that's general. That's
It's all NLP multi-language concepts. Yeah, we can go.
It's all NLP.
Yeah, really. So internally, Bhavesh, we want to understand what is happening. I mean,
Yeah.
at least,
Yeah. Yes. So now we'll come to the things to keep in mind section. I don't have a lot of points here, but I'll just explain it over. So the first thing is we built our Docker image. So the Docker image is being built for our model, and we had a model and source folder separately, right? So the source folder that we had put our requirements, our inference py and main.py, all of that. So that part, all of the files inside the source folder are what is included in the Docker image. All of our model files from the model folder are not in the Docker image. They're actually stored somewhere in a storage server. So specifically, if it is Elastic File System, which is a network file storage. So we store the model files there, and so we do that. So once that the build part is done, then we deploy the model. Now, when we're deploying it, this Docker image is pushed to this Docker is pushed as a repository to Elastic Container Registry. And then we basically use a Lambda function to take this to run this Docker container. And Lambdas can also connect to network file storages. So Elastic EFS is connected to that Lambda function. And so that we can access our model files, right? So because model files are not present in the Docker image, even though they can be if you wanted to, but that's not ideal for speed issues. Like the speed will be very slow if you include that as well in the Docker image. So we don't want to make our Docker image bulky. So we just use that Lambda function, and then we make our API request, which invokes the Lambda function and returns us the response. In Lambda, there's a thing called cold start and warm start. So because this is you're only paying for your number of invocations and not the idle time. What it does is after a particular period of time, it's not specified. It's actually very variable depending on traffic and all. It will actually go idle. So it's loaded out of memory. It goes cold. So we call that cold.
So Bhavesh, one doubt here. So for calling the Docker container model, we are using Lambda, right? Or
yes.
Okay.
Yeah, so the Lambda essentially goes cold, so it's not loaded in memory anymore. So that's why when you and also when we are making this API call, we are using actually API gateway to connect between Lambda and the client. And API gateway has a timeout limit of 29 seconds. So even if Lambda can run for at least 15 minutes, API gateway is restricting us only for 29 seconds. So that's why when you initially when you run your model for the first time after a while, because it's cold, it will take time and it can time out, and that's why we see that endpoint timed out sort of thing. Yeah, so that happens. But generally, like your inference is still continued behind the scenes, even if it times out, if it was successful. But otherwise, the way to get around this is the like very soon in the near future, you can have an extra API. So there will be an extra API or an extra URL that you can just make a ping sort of call. So specifically, so that you can load your model into memory before you are getting it ready for inference. So this is actually same for Hugging Face also. Even Hugging Face, when you make your inference for the first time, it actually takes a really long time because it's loading in memory for the first time, but then the subsequent invocations are faster. So we'll be, but we'll be separating the loading part. You can like opt for, like, you can just make an API call, or you can, even if the ping is not available, you can just, whenever you're, let's say you're deploying it as a web application, whenever you open up the web application, it will in the background, it will automatically make a dummy API call to the model so that the model is picked up. And then whenever the user makes prediction, it will be ready, quite ready for inference. So, but I guess in the probably by the next workshop, we'll have this API, this loaded model API ready, so that can be used to load the model into memory before the inference. And yeah, so this is how this thing is working. So you have again to keep it warm, though, you can technically like keep on pinging it for after a while, but that will consume your invocation call for nothing. So that's may not be the optimal method. The optimal method would be to just load the model when the web application or when your client is accessing or logged in, so that you load the memory and then make the predictions because the user will manually make the predictions, right? Or if you are using in the server side, then you can, whenever your server is running, you can just load the model first and then use it by just pinging it. Some other things to notice, again, this is a synchronous API version only. You might have seen in the URL of our API. It was making calls. So we were making calls to this URL, right? api.cellstrat.com/synchronous. So synchronous means is it's like real time, or like when you give the call, it will return the response in the same call only. So it will not wait for anything else. So it's so this is synchronous, and it has again 29 seconds limit. So this is not suitable for batch inference. So for batch inference, there will be an asynchronous API where you make where you send the inputs first, and then later on, after a while, you can fetch the results from the server by making a separate API call. So by two separate API calls, because that's how asynchronous APIs work. So that will be used for batch inference, and that is in the roadmap. So currently not available, but it will be available in the roadmap soon once the synchronous and everything is stable. So
sorry, maybe you have explained it, Bhavesh, but sorry to ask you again, but what is synchronous? What is the main difference?
Synchronous is, let's say I give you some input, I wait for the output at the same time. I don't like I talk to you and you give me response.
Okay, real time.
Yeah. Yes. Asynchronous is I give you the input, so it's like batch job. Asynchronous is like batch job. You send your inputs, and then you, let's say, go to your work, do your work, and then maybe after 30 minutes or 1 hour, you come back and check if the results are ready or not. So that is asynchronous.
Let's say we want to do inference on 10,000 images, so it will not be done as a real time.
Like it's not possible to wait for 1 hour continuously, right? You just send your inputs and then be free, and then later on come
So
back.
that will be a workflow based calling. So there'll be a trigger, and then you log off. Then after some time, you'll get a ping that the batch is ready, something like that. So a workflow will have to be created, an API workflow.
And yeah, so we'll do that once the synchronous. If you noticed, we are still in beta. So if you have any feedback, or if you get any bugs or want anything, you can just click on this to open up a Google form, which will give the feedback. So feedback is appreciated. That will help us improve the platform. So we can do that. And also the documentation is also extensive. We are currently still, again, we are frequently, like every other day, we are adding more things to the documentation. So the documentation is available at docs.cellstrathub.com, which is accessible here by clicking on this, as well as by clicking on the documentation, the helpful resources here. So you have different resources like documentation, quick start, FAQs. FAQs are low connect, but quick start on the and so on. Yeah, so So the deployment section is here. So currently we have the quick start. We'll soon be adding these things that I talked about right now, also in the documentation soon. And the development itself is quite extensive and feature rich. There are a bunch of features. I still haven't covered a lot of them, but if you notice, there is actually something called code snippets where you can actually save your frequently used code snippets here. So you can also, let's say I want to save this snippet here. I can right click it, click on save as code snippet, give it a name like and just save it. And let's say I want to use this snippet again later in my other project. I can't, like usually I would have to like find out where my old code was involved, right? But here you can like just click on this and click on insert snippet. And this works for scripts and apart from this, there are also some other things like real-time collaboration. So you can actually use a share to have two users coding on the same notebook at the same time. So in real time, like Google Docs or that sort of thing, right? Where in Google Docs you can real time can make collaboratively edit documents, right? So that is also there. Yeah, so there are a lot of features in the workspace itself. In the deployment as well, again, there's plenty of flexible combinations that you can do. So yeah, but this is a complete series of workshops that we'll be doing, I guess, probably every week or every other week or something on CellStrat Hub, so deployment as well as other parts. Yeah, so if you have any questions, you can ask, but that's essentially it for today.
Bhavesh, maybe it's a naive question. Can you just throw some light on Docker container, that concept?
Yeah, so Docker containers are essentially a way of packaging your software with all of its dependencies and operating system requirements in one thing. So generally, let's say I have some code that is running on my machine, but it's not running on your computer because maybe you have different libraries already installed or your environment is a bit different. So then it's a bit hassle, right? Then I tell you how I set up my environment, we just debug and all of that. With Docker, however, what I can do is I can package all of my code into a single Docker image. And the only requirement is you should have the Docker installed and you can actually use that Docker image to run the code without worrying about libraries, dependencies. So let's say I have my software built for Linux, but you have a Windows computer, but still you will be able to run it because the Docker container will include the scope operating system as well as the dependencies.
It's a virtual container like VMware.
Yeah. So so it's essentially idea is basically like a virtual machine only, but the difference is that virtual machines are very bulky, but Docker is very light.
So I think virtual machines uses operating system. No, Docker doesn't require it because that's only.
Like it virtualizes the. Actually, what it does is it has a Docker kernel which will actually simulate the operating system. So in my case, we are actually using a Buster operating system. So it's called it's a Debian based operating system that the model is deployed currently. And but essentially the OS parts is also there.
So on top of one OS, you can deploy multiple Dockers. That's what the meaning, right?
Yes.
So it becomes light.
So I guess there is also there's I think
and one more, Bhavesh, here, as you said, like, see, we use Lambda to call our Docker container directly, or what is happening? I mean, it is running on a EC2.
It's actually Lambda is actually a managed serverless function. So serverless is essentially that
AWS Lambda
Docker based only. So it's you don't really pay for the time, you only pay for the number of invocations and the compute time that you use.
So we use only AWS Lambda here. What is the EC2?
Yes,
what we are using here? We're not using EC2.
Actually, EC2 is only for this development environment that you're seeing. This is
okay.
Based on
for deployment basically.
Only for
I think no, development also we can do in our own local, right? So EC2 is not required.
Development you can do in local, but for deployment you will still need to use this.
Okay. So EC2 we are using for deployment, and then while running, it is running only using Lambda.
This EC2 is essentially your own personal computer on the cloud that you are using with CellStrat Hub. So call that workspace. Yeah, and again, maybe in the future and all, we will be actually providing free GPU or cheaper GPU as well.
So essentially,
you can actually completely replace Colab as well.
So essentially, inside CellStrat is using mainly EC2 and one Lambda. I mean, these two services.
Yeah, right? For development, EC2 based environment, and for deployment, Lambda.
Deployment and running. Execution also, right?
Sorry, what
Execution. I mean, basically, when you call a API from
model.
model.
Yeah, that.
Okay, yeah.
And also, this is like a general explanation when we compare virtual machines with containers. So, in a virtual machine, we have our hardware, and then we have a hypervisor, and then we virtually create a guest OS and then run our libraries. But in containers, we have a container engine which will actually simulate that stuff. And plus, containers are really light in weight.
Okay. So the Docker file creates a container basically, right?
Yes.
Okay.
So here, this is one container. This is one container. All these are managed by Docker Container Engine or a DC.
Okay.
So it will handle running the Docker container and emulating the operating system.
Okay.
So are you using any Kubernetes also here, or no Kubernetes use, right?
Yeah, right now no. But for the asynchronous API, we might.
Okay, for orchestration,
for the
right?
Batch for the batch inference, because Lambda will only work like it has a 15-minute timeout limit, and batch inferences can take hours.
No, exactly. So you should, if you have around 10 or 15 API calls in the batch process, you should slowly do one by one, right?
Yeah.
So for that, you use the orchestration. Okay. Got it.
So in AWS, there are actually two orchestration services. One is either Kubernetes, which is an open source one, or the Elastic Container Service, which is
for AWS.
proprietary. But either one can be used to check for this.
So, but here you are using all AWS services only, right? For CellStrat.
Yeah, AWS services.
Okay. Yeah.
Okay, so excellent workshop. So folks, any final comments or questions?
I think it was a great delivery of the session also. Like I liked it, the way we can easily deploy the model. I mean, we can spend more time on the model development itself, so the deployment will become easier for us.
Yeah.
Thank you,
Yeah,
Bhavesh.
it's a good one, Bhavesh. Yeah.
Okay, thanks a lot, Bhavesh. Thank you all, audience. Thank you for joining. Any comments?
Thanks a lot, Bhavesh and Vivek.
Yeah, thank you, everyone.
Thanks,
Thank you all.
Vivek. Thanks, Bhavesh.
Thank you all. Have a good day.